Hello everyone, myself Samir Rahul, and today I am going to present you all the Capstone project of Module 6, that is Machine Learning Module. The name of the project is Health Insurance Cross-Sell Prediction, and this is a team project in which myself Samir Rahul and Lekha Damre have done the work on this project. So let's get started. So the project summary is the objective of the project is to develop a classification model to predict whether a customer will be interested in purchasing additional vehicle insurance or not. This predictive model will enable us or the insurance company to identify potential customers more effectively, thereby improving marketing efficiency and customer outreach. So the data which I have taken here is this data in which Max Life Insurance have given the data for their health insurance, and using the data we have to predict the customer prediction. Okay, so overview of the data is given in the summary. What we are all going to do in this project, we are going to explore the data analysis, then we are going to model that particular prediction model, and then we are going to conclude all the things. So this is a GitHub link, and now let's talk about the problem statement. So the problem statement is the predicting customer interest in health insurance cross sell. Okay, and the objective remains the same, that this develop a project to develop a machine learning model that can predict likelihood of customer being interested in purchasing a vehicle insurance policy. Okay, so let's get started. So first of all, I have imported a important libraries such as NumPy, Panda, Matplotlib, Seaborn, some pre-processing and pipelines also from sklearn, using sklearns, and at last warning. Then load the data here, data pd.read csv. Then let's check the data set first loop using df.head. Now we are going to check the shape of a data, that is it contains 381,109 rows, while the number of rows or feature columns are 12 columns. Now we are getting the information about the data sets. So these are the 12 columns we have, their null value count and their data type. Now let's check for the duplicate values. So if we check the duplicated function, there are 0 duplicate entries in the data set. And if we want to check the missing values or null values in the data set, we can see that there are 0 null values all over the data set. This is a graphical representation of a null values. So we can say that any there are no null values present in the data set. So what did you know about your dataset? The dataset consists of a 12 feature columns, as we have already seen, with total 381,109 rows. It contains no null values across any of the feature, and there are no duplicate entries. Now we are going to check for the columns present in the dataset. So ID, gender, age, driving license, and so on. All these are the total columns we have in this dataset. Now this is the description of integer or numerical columns, where we can see the count, their mean, standard deviation, minimum value, first quartile, second quartile, and third quartile values. Also we can see the description of a categorical feature columns. So which are the most frequently valued, uniqueness and frequency and total count. Okay, so the description of their variables is id, gender, age, driving license, and so on. This is to check the unique values. So we can see there are 381,000 records. So their male, female, age is 66, driving license 2 unique values, that is 0 or 1, that is yes or no, and so on. We have performed some data wrangling code, data wrangling here, that is typecasting or data type we are changing from integer to string. Then checking again. This is a code to check the categorical column, numerical column, continuous column, and descriptive column, which we are going to This is going to help us in the future machine learning prediction model. Okay. So we are creating a one function which we are going to apply in this um, df.edge group column. We are going to create using the original edge column, and then we are going to derive some statistical data like mean, standard variation, standard deviation, median, and quantile. All the things we are going to get through this code. When we run this code and summarize it, we can see that we get the mean, median, standard deviation, variance, first quartile, third quartile, IQR, then range, outlier, upper bound, lower bound, and percentage outlier. Okay. So we can see that we have a 2.71 percentage of outliering annual premium. So we are going to check with the help of box plot again. So this is a code. We can see that these must are the outliers present in the annual premium column. So we are checking the outliers in the upper bound and lower bound value. So we can see that in the annual premium column there are 10,000 and 10,320 outliers present, which approximately is 2.75% of the data set. So we have to work on it, and to work I have performed this code, and then I have clicked the data into the main data frame. Okay. So what all manipulations have you done and insights you found? So converted data types of region code and policy sales channels from float to string. Then created an age group column from original age, where young for ages under 30, middle age for from 30 to 50 years, and old for 50 above 50. So then develop a custom function to generate summary statistics. We have seen already. Checked and percentage of outliers using the IQR method, and we are seeing that dropped outliers in the annual premium column, which accounted for 2.71% of the overall data. Now we are going to perform a EDA on this dataset, where we are going to plot some charts and draw some conclusions. Like this is the distribution of age. This is the distribution of age by gender, like male and female. This is a vertical line for mean age, that is 38.67 age. Then another chart is for distribution of annual premium, and same for the annual premium by gender. Then we are seeing the distribution of vintage, which is mostly a uniform distribution. Then we are checking the gender distribution, that we can see that 54% of the data is derived from the male data set, male gender, and remaining 46% are the female. Similarly, this is the data of how much of the median annual premium paid by the females and the males. So we can see that 29,285 is the median annual premium paid by the male, while the 29,240 is the value of annual premium female paid on average. Okay, so this is the annual premium data for the vehicle age. This is the response distribution, whether the customers are interested to take to buy insurance or not. Similarly, we have this is all EDA we have done. Okay, this is annual premium versus vintage scatter plot. This is the top 10 region by count. So from 28 code region code, we received the most of the insurance. Okay, so this is top 10 policy sales channels by count. Channel number 152 is the most selling channel. This is a correlation map, and this is a uh, pair plot. I have plot using the pair plot function. So this is it. Now on this data set we are going to perform some hypothesis testing. So this is the first hypothesis, that is the average age of individual in the data set is 35, and the average annual premium is greater than $25,000. And third hypothesis is the proportion of males and females in the data set is equal. So testing for the first hypothetical statement using uh, using t-stat method. So we can see that the p-value is 0.05. So we will reject the null hypothesis, and the mean age is not equal to 40, and we know that it is a 35. so we can reject the null hypothesis. In the second statement, we can say the average annual premium plan is less than 30,000. So let's check the hypothesis. This is also checked using the t statistics method, and we can here also fail to reject the null hypothesis. The mean annual premium is not greater than 30,000. And the third is the state your research. Okay, so the proportion of male is the population is equal to 50, and the proportion of males in the population is not equal to 50. So for this statement, for to prove this, I have used a z statistical method, and by using this we can say that we can reject the null hypothesis, and the proportion of male is not equal to 50. We can prove that. Okay, then we have done some feature engineering and data pre-processing on the data set. So these are all the done. And then again, handling the outliers in the annual premium. Okay. So after removing the outliers, we can see that there the new plot is plot, it looks a little bit of double curvature normal distribution, so it is okay now. Okay. Then we are going to handle the imbalance data, because we can see that there is a 3,34,000 count for the zero response, and 46,701 count for one response, that is yes response. So we are going to balance using the random over sampler method. So I have imported a random sample over sampler, and then we can check now the count get balanced. Okay, so we are going to use this. Then I'm going to split the data to train and test the module. So from sklearn model selection, we have imported train test split, and then perform this splitting, and then using this all the data to do the manipulation using ML model. Now we are going to do the data scaling also using standard scaler, and then now we are going to prepare the thing for the ML modeling implementation. So I have imported some logistic regression decision tree classifier, random forest classifier from this sklearn to perform the model. Okay, so first model I'm going to train the dataset is logistic regression. So using logistic regression, I have trained the dataset, and to get all the things, I have done this coding. We can say using model logistic regression model, we are getting 0.78 per accuracy, and the recall value is 96, so which we can be increased in the future. So this is a confusion matrix for logistic regression, and this is a ROC curve for logistic regression model. Then another model is decision tree model. So using decision tree model, if I try to predict or train the model, I am getting the accuracy of 0.994, which is way better than logistic regression accuracy. Okay, so similarly here also I have performed the confusion matrix and ROC curve for the decision tree model. Okay, and at last I have performed another machine model, uh, that is random forest. I have trained the model using random forest, and we can see that this is also getting a close to 95% of accuracy. So this is also better by the in comparison to this decision tree, and way better than the logistic regression. And similarly here also I am going to perform the confusion matrix and ROC curve, which is equal to 0, sorry 1. So we can see that the random forest is the best fitted model for this particular data set. Okay, so now this is a code to check which model performs the best. So we can see model 1, that is logistic, is below the threshold. Model 2, it's up to the threshold, but model 3, that is random forest, is above the threshold. So we can um, say that model 3, that is random forest, going to work for this data set. So the chosen model is model 3, that is random forest. Why? Because of the accuracy. Model 3 has the highest accuracy. Recall, it achieves the highest recall. It is also a precised, and the F1 score is 0.95. All the scores are the best in comparison to the remaining two models. So that is why we have chosen the model 3. So explain the model which is you have used, and future importance using any model explain related to. So this is the code I have done. So to get the importance of features, features are the column, and we can see their importance. So highest important we get from for the remainder vintage, then annual premier, vehicle damage, age, previously insured. These are the some features we get. We can say these are the most important for the this model, and the scores are here. Vintage, it is 0.20 and so on. So for this project, I used a random forest model. The random forest algorithm is a versatile and robust ensemble learning model that combines multiple decision trees to improve predictive accuracy and control overfitting, which we have seen using the random forest modeling. Okay, feature importance. To explain the feature importance, I use the random forest model inherent feature importance scores. Here, why the key features were selected: vehicle damage, yes, and annual premium. This feature have high importance score, indicating that past vehicle damage and annual premium amounts are strong predictors of customer inherent in purchasing vehicle insurance. Similarly, previously insured. This feature is also crucial because customers who are already insured might show different behavior compared to those who are not, and similarly, so on. So this is the future work I have done, and I have saved this model for the for the future use, also using Joblib. Okay, so in this way, in this machine learning capstone project, we have successfully developed and evaluated a predictive model. The final model of achieved an accuracy of 94.89%, which is close to 95% of accuracy, and a recall value of 99.83%, precision value of 90%, and F1 score of 95%. This metric indicate that the model performs well in the correctly identified positive cases while maintaining a balance between precision and recall. So this is it from my side. If you have any question, please free feel to inform me. Thank you.